Singleton is one of the simplest design patterns that one can think of. What is it? In many situations, we have only one object of a certain class. So, for example, in a computer system, you could have many printers, but there is a central spooler, and that collects all the print jobs and prints them on the printer. There is only one spooler, although there are many printers. A company has only one president, or a single processor system can have only one CPU. And you could have corresponding object-oriented systems of some of these things. For example, you could have a company implemented, and then there could be a class called president, and there is only one instance of that. Or if you think of a university, there is only one president for it. There may be only one collection of all the faculty. It is possible if it is a small university. So there are many places where, many instances where there is only one instance of any specific, of many specific classes. So in those cases, how do you arrange matters so that no one can instantiate more than one object of a class? And this is the typical solution. Suppose we have a class B that you want to be a singleton. This class cannot have, should not have, must not have more than one instance. So if you provide a public constructor, then anybody can create an instance of that class. So we don't want to do that. So we have to make a private constructor. So private B. So that is one thing. But then how can you actually create an object? How can somebody from the outside create an object? So you can't have an instance method create an object, because that itself requires an instance. So that is catch-22. So what we do is provide a static method, perhaps called instance, and we can call this method by writing b.instance, right? Instance is a static method, as you can see. What it does is it creates a singleton, it creates the only instance of B and returns it, provided there is not already another instance of the object. So we have this arrangement where we have a field called singleton of type B, which is static. This stores the reference to the only object of type B. So what we do is this: if b.instance is called, we check, is singleton null? Has there been an object created of type B? If there has not been such an object, we create an instance of B. We can call this a constructor from here, because this is within the same class, and store that in singleton. Now singleton contains a reference to the B instance, and we return that. Next, b.instance, singleton will not be null. We will not be creating a new instance, and we will be returning the object that we already created. And there can be many instance methods here to deal with application related stuff. So you can see some features of a singleton in this slide. One thing is that clients need not maintain a variable to keep track of the instance. You can always get the instance by typing b.instance. That will always return the singleton object. So any code that can access B can write b.instance. That you don't have to store that reference anywhere, that object reference anywhere. This can be subclassed. You can have subclasses of B that themselves are singletons. You could, instead of having a singleton, you could have all static methods. Then you could get the same functionality, but then static methods cannot be overridden. So you can't have those methods, but you can't override them. So you can't really have true subclasses in the traditional sense.